this is your tutor AB, and today we're going to be solving an IB physics problem from the November 2016 IB examinations. This is paper 1 physics SL, and this is question number 23 on that test. So let's solve it, shall we? So, the question: on Mars, the gravitational field strength is about 1/4 that on Earth. The mass of Earth is approximately 10 times that of Mars. What is the ratio of the radius of Earth to the radius of Mars? Okay, this is a ratio question, and so we need to understand before we even get started that this will require cancelling out terms and writing two equations with in respect to the same variables so that they can cancel out in the end. So keeping that in mind, let's get started. The main equation we want to use is the gravitational field strength equation, which is G is equal to gravitational constant, capital G, into the mass of the planet over r squared, the radius square of the planet. Now, based on this equation, we're going to be solving this question. So, first, let's find a gravitational field strength for G, because this equation includes a radius, and so I'm assuming that at the end, if I use these equations, the rest of the variables get cancelled out and I can isolate the radius so that I can get my answer. So let's get the gravitational field strength for Earth. For Earth. Let's write a base equation. Let's keep it as our normal equation. G is equal to gm over r squared. This can be for Earth, our base equation. Now, based on this equation, we're going to write a second equation for gravitational field strength of Mars using as many similar variables as possible so that we can cancel out at the end. We know that the gravitational field strength of Earth is 4 times stronger than the gravitational field strength of Mars. So we can say G dash, which is the gravitational field strength of Mars, is Earth's gravitational field strength divided by 4. Is that not what it says right there? So we're just using that for our question. So let's write an equation, shall we? For Mars. Okay, so we can say G dash, the gravitational field strength of Mars, is equal to the gravitational constant multiplied into the mass of Mars, which we know is 10 times less than the mass of Earth. So using the mass of Earth divided by 10 gives us the mass of Mars. This whole thing divided by x squared, which we're assuming is the radius of Mars. These are the x squared, and r squared is what we're going to need at the final ratio. So for G dash, let's substitute G over 4. So we know G over 4 is equal to gm over 10 whole thing over x squared. And now let's get x squared and r squared in the left side of their respective equations. So we get that x squared g is equal to 4gm over 10, and we want to get this x squared alone, so we can say that x squared is equal to 4gm over 10g. That's our first equation. Second equation is just rearranging the gravitational field strength of Earth, so that can just be r squared is equal to gm over g. Now they want the radius of Earth over the radius of Mars. So let's just do that together. We have r squared and x squared, and we'll take a square root at the end to get our answer. So we want r squared over x squared. So we'll simply just do gm over g whole thing over 4gm over 10g. Now this is just equal to gm over g. We take the reciprocal, 10g over 4gm. Now we cancel out any common variables. This is why it's important to keep as many similar variables as possible. gm and gm go, g and g go. So we're left with x squared over r squared is equal to 2.5, 10 over 4. So let's go down. If we just say that x over r is equal to the root of 2.5, which is approximately 1.58, which again we can equate to 1.6. So our final answer is C, 1.6. Thank you.